This integral cannot be solved using traditional integration methods. And the integral I'm talking about is labeled the capital I is equal to from integral from 0 to infinity e to the negative x squared dx. Here is how you proceed into solving this problem. First of all, let's square this, okay? You agree with me that I squared is equal to 0 to infinity e to the negative x squared dx times from 0 to infinity e to the negative x squared dx, right? There's no problem here, right? Like I just multiplied this value twice. That's squaring it. Okay, now here's where things get a little interesting. E to the negative x squared dx is the same thing as e to the negative y squared dy. I didn't do anything new here. All I did was switch the x with the y. I'm allowed to do that. There's nothing different about this integral. So that means it's 0 to infinity e to the negative x squared dx times 0 to infinity e to the negative y squared dy. And what you're allowed to do at this point is say from 0 to infinity e to the negative x squared minus x squared, y squared, x squared minus y squared dx dy, but dx dy is the same thing as dA. And if it hasn't become obvious to you at this point, we're going to be using polar coordinates to solve this problem. Sorry, also 0 to infinity here. We're going to be using polar coordinates to solve this problem. The region we're integrating over looks something like this. X, y, and our radius, our quarter circle radius, our radius r is equal to infinity. It goes to infinity at the very least. Okay, so now what we do here, this is just a calculus 3 problem at this point. Okay, here's what you do. X squared minus y squared is r squared. So I'm going to leave these two integrands blank for now and consider this. So it's e to the negative r squared. And in polar coordinates, dA becomes r d theta. And your value of your radius goes from 0 to infinity. And your angle, it's the first quarter part of the circle, right? So it's just 0 to pi over 2. Okay, and doing that, you could use the substitution method or anything. I think I just did this one directly by using using trig substitution. That is what is it? I think 1 over 2 e to the negative r squared. Yeah. Mm-hmm. Yeah. Negative 1 over 2 e to the negative r squared from 0 to infinity and d theta, which is pi over 2 times negative 1 over 2. I can't have this infinity looking like this. So what I'm going to write instead is lim as a goes to infinity. E to the negative r squared, a 0 this part here is negative pi over 4. And then this part here, it's e to the, I still have to do the lim as a goes to infinity. E to the negative a squared, or yeah, a squared, minus 1. Okay, well, e to the negative infinity, as that value goes to 0. Yeah, as the a goes to infinity, e to the negative x goes to 0. So yeah, this part cancels out. Negative pi over 4 times negative 1 is pi over 4. But we're not done yet, because this is actually the value of I squared. So that means, so we have to take the square root. So I is root pi over 2. And that is the value of our integral from 0 to infinity, e to the negative x squared dx. I hope that video was helpful.